Astronomers have been puzzled by a strange phenomenon for decades. Since the 1950s, thousands of stars have mysteriously disappeared. These once bright celestial objects, which regularly lit up the night sky, now seem to have vanished without a trace, and no one knows exactly why. In this video, we'll explore what scientists have uncovered about this perplexing disappearance and dive into the leading theories about where these stars might have gone. So stay with us until the end to uncover the truth behind one of the universe's biggest stellar mysteries. In the grand scheme of the cosmos, every star eventually reaches its end. From that perspective, it may not seem so unusual for a star to fade away. After all, we understand that stars are not eternal. They shine for billions of years, but ultimately they die when they exhaust the fuel that powers them. A star glows because the immense gravitational pressure within it generates extreme heat, triggering a process known as nuclear fusion. In this process, lighter elements like hydrogen fuse into heavier ones like helium, releasing enormous amounts of energy in the form of heat and light. However, this fuel doesn't last forever, and when it runs out, the star's brilliant light must come to an end. Once the hydrogen in a star's core is exhausted, the delicate balance between gravitational pull and radiation pressure is disrupted, causing the star to undergo dramatic changes. What happens next depends largely on the star's mass. Smaller stars like red dwarfs experience a rather uneventful end. They gradually cool over time, eventually becoming white dwarfs. Stars of medium mass, including our Sun, expand into red giants after burning through their hydrogen. During this phase, helium starts fusing into heavier elements. The star then sheds its outer layers into space, forming a colorful planetary nebula. What's left behind is the hot core, which contracts into a white dwarf. In contrast, massive stars meet a far more violent fate. These giants undergo multiple stages of fusion, forming heavier and heavier elements up to iron. But once iron forms, fusion no longer releases energy. As a result, the energy balance collapses. The star implodes under its own gravity, triggering a powerful supernova explosion. The outer layers, flung into space by this cosmic blast, can later contribute to the birth of new stars or planets. In the aftermath of a star's life, either a neutron star or, in the case of particularly massive stars, a stellar black hole is left behind. This leads us to the puzzling phenomenon of the missing stars. It's clear that stars do at some point disappear, but that's only part of the story. What's truly important is that they usually leave behind something observable. They don't simply vanish into nothingness. Take white dwarfs for example. Although small, they're still hot and emit a visible glow. Supernovae, too, rank among the most brilliant events in the universe. Neutron stars can be harder to detect, but scientists have managed to observe them nonetheless. And while black holes themselves are essentially invisible, the supernova explosions that precede them are anything but subtle. So, if thousands of stars have been disappearing from the night sky since the 1950s without any accompanying signs, no supernova, no white dwarf, no detectable remnants, that represents a serious astronomical enigma. This mystery traces back to July 19, 1952. At exactly 8:52 a.m., astronomers at the San Diego Observatory captured a photograph showing 3 stars clustered together. Yet, less than an hour later, those same stars were gone without a trace. And this wasn't a one-time anomaly. These unexplained disappearances have occurred repeatedly, leaving scientists mystified even today. To dig deeper into this cosmic puzzle, the VASCO project was launched in 2020. VASCO, short for Vanishing and Appearing Sources During a Century of Observations, aims to compare historical sky images with more recent ones, searching for anomalies. The team began their work with data from the Palomar Observatory Sky Survey, POS, which was carried out between 1948 and 1958 in California. Through this effort, researchers hope to finally shed light on one of the most curious mysteries in modern astronomy. The researchers then compared the old photographic plates with modern astronomical surveys, specifically the Pan-STARRS DR2 database from 2019, which includes 10 billion entries, and the Gaia DR3 catalog released in 2022, which added 1.8 billion more stars than all previous surveys combined. With this data in hand, The VASCO scientists began the complex task of cross-referencing all three datasets. However, this was no simple undertaking. Due to the massive scale of the project, manually counting and comparing the objects was out of the question. Automation was essential. Complicating matters further was the fact that more than 50 years had passed since the original POS catalog was created, meaning the coordinates had to be updated. Additionally, the older images were analog photographs, while the new data is entirely digital. Another critical factor is that stars are not stationary, they constantly shift positions in the night sky. While these movements are subtle enough not to disrupt the original photo significantly, anyone aiming to create an accurate comparison, as the VASCO team intended, must factor in stellar motion. Simply looking at the exact same spot in the sky would not be enough. The experts considered all these factors and many more when designing automated search and comparison programs. After the initial analysis, they identified nearly 300,000 objects that were still listed in the old POS catalog, but were completely absent from newer ones. While this is an extraordinarily high number, further cross-referencing with other catalogs helped reduce it significantly. Still, nearly 10,000 stars recorded on film in the 1950s appeared to have mysteriously vanished. This raised serious questions. After all, 10,000 missing stars is no small matter. So, how did scientists respond to such a puzzling situation? Their first step was to confirm whether all of these objects were indeed stars. Given the sheer volume of data, it's simply not feasible to inspect every individual point of light manually. With that in mind, it's entirely possible that some of the light sources in older catalogs were not stars at all, but instead other celestial bodies, most likely asteroids. These objects naturally continue moving through space, which would explain their absence in more recent images. Fortunately, this hypothesis could be tested. As a result, the number of unexplained missing stars was further narrowed down to 926. A deeper analysis of the data centered on the brightness variability of celestial bodies. Stars, after all, don't always shine with constant intensity. This variability can be caused by internal processes within the star or by external factors like companion stars or surrounding dust clouds. Some stars, particularly Cepheids, are known to breathe regularly, expanding and contracting, which causes their brightness to fluctuate over time. In addition, stars can influence each other, sometimes obscuring one another from Earth's perspective. Sudden outbursts, material ejections, dust clouds, and even passing planets can also create the appearance of flickering. This principle was applied to the VASCO project. It suggests that a star bright enough to be photographed in the 1950s could have simply been in a dimmer phase during modern surveys, making it appear as though it had vanished. When comparing data from different sources, researchers confirmed this explanation in 35 cases. However, 9,171 stars still remained unaccounted for. So, where did these missing stars go? Sometimes the answer to such cosmic puzzles isn't found in deep space, but in the technology we use here on Earth. After experts carefully examined the images for potential errors, such as optical distortions, scratches on old photographic plates, or issues during data digitization, the count of missing stars dropped again, this time to 5,579. A final analysis then focused on stars with unusually high velocities, which may have led automated systems to misidentify them as different celestial objects. In the end, 5,399 stars remained unaccounted for, forming the core of the mystery. The intriguing part is that for these stars, we simply can't say with certainty why they were once visible, but have now vanished. This has led astronomers into the realm of fascinating theories. One such theory involves what are known as dark supernovae, massive stars that collapse directly into black holes without producing the typical bright explosion. Also referred to as failed supernovae, the collapse of the star's iron core either generates a blast too faint for detection or causes the outer layers to fall back into the core before they can